Hi, everybody. This week we're going to be talking about chemical reactions. And so this is actually, oh, my gift's not playing. There we go. This is one of my favorite demos to do. This is called a carbon snake. We just start with a little pile of sugar here, and we add some really concentrated sulfuric acid. Give it a little bit of energy with that flame just to get it going, and it decomposes. So, sugar is made of carbons and hydrogens, and it decomposes into carbon, right? So this carbon snake, we call it that because it's carbon. Really cool reaction to see. So we're going to take a look at some of those chemical reactions that we talked about last week, and we're going to add them to our notebook. All right, this is how your notebook should be set up on page 32. If you haven't done it already, take a minute to get it set up. For each of the reaction types, you're going to add the definition and the ABC model that is on the screen for you. And we just have a few definitions we're going to start off with today. All right, our essential question for today is, how do we write and talk about chemical reactions? All right, so this is the same chemical reaction that we took a look at last week. Remember that the reactants are the things on the left side. These are what you put into the reaction. And so we had a word that we used to describe reactants last week, and we'll include that in our definition. These are ingredients. Okay? And then the products are all the things on the right side of the equation, or the pointy end of the arrow. Okay? These are what are made from the reaction. Okay? So one thing that we want to add to this, when we say that what is made from the reaction, we're talking about new substances. All right, and then a couple of the chemical symbols. We didn't really talk about this plus sign last time because it's pretty obvious. It's the same thing um, that we use it for in math, right? Add. It means that all of these things are put together on that side of the arrow. And then the arrow itself has a name, right? And so let me write that on here for you. Okay, so the arrow is called the yield symbol, and the yield symbol separates the products and the reactants. It shows the direction of the reaction, right? So because the arrow is pointing this way, whichever end the tip of the arrow is at are your products. All right, so we're going to take a look at those 5 types of chemical reactions, and you can tell which type of chemical reaction is occurring just by looking at the substances that are in the chemical equation. So here's our first one. Take a moment and copy down the definition for a combustion reaction and the ABC model for the combustion reaction. Right, so a combustion reaction is a carbon-hydrogen fuel reaction with elemental oxygen to produce water and carbon dioxide. So remember, we talked about how this can be any hydrocarbon or carbon-hydrogen fuel. That's why we have an X and a Y here, because we can have different amounts of carbon and hydrogen that make up the fuel. And in this case, this candle is actually a carbon-hydrogen fuel called paraffin. Right? So wax is a carbon-hydrogen fuel. That's why we can use it for candles. And this candle will burn as long as there is O2 gas available inside this jar. And so eventually the candle goes out because all of the oxygen is used up. And do you see how this water level rises? That's because as this O2 is used up, this water goes up to take the space of the gas that's been taken out, right? So we've actually produced more water and we've produced some carbon dioxide, but we've reduced the amount of gas in here and the water takes its place. It's a really cool demonstration of combustion taking place in a closed container. All right, a synthesis reaction is the formation of a new compound by combining different substances. All right, so if you take two or more reactants, so two or more substances, and combine them to form a single product. This is an example we looked at last week where we had sodium metal, Na, and we had chlorine gas, Cl2, and they combined to form sodium chloride, table salt, right? So we had one compound in the end. So here's the ABC model. If you have substance A and substance B on the reactant side, they will combine to form a single compound over on the product side. Rust is another example of that. So rusting is where you have iron and it reacts with oxygen in the air to form iron oxide. All right, decomposition reactions are the opposite of synthesis. This is where we have one reactant and it breaks down into two or more products. Okay, so our ABC model is here. Here is our compound, and the different parts of the compound become separated. All right, usually a decomposition reaction requires energy, right? Because we're separating these substances that are stuck together, right? They're bonded together. Those valence electrons are forming a bond. So we have to put in energy to separate them. With this example, we have mercury oxide, and as we heat it, the oxygen is separated from the mercury to form oxygen gas and elemental mercury. Alrighty. A single replacement reaction is where one element replaces another element to form a new compound. So we have a single element here, we have a compound over here, and you're going to have one element replace another element. An example of this would be the reaction between copper. So here we have a copper wire and silver nitrate solution. So this clear solution is silver nitrate. And over time, the copper atoms from the wire change places with the silver atoms in the silver nitrate to form a new substance, carbon nitrate, which is this blue liquid here. All right, so this new blue liquid and silver. So metal can actually form crystals when it precipitates. It's kind of cool. But these are little crystals of silver metal. Then we have a double replacement reaction. So a double replacement reaction is where the metal of one compound replaces the metal of another compound. All right, so in a double replacement reaction, both of our substances in the reactant side are compounds. Okay, so these are both compounds. And just the first part of the compound are going to swap with each other. Right, so now we have AD and CB. We have two new compounds. An example of that would be the reaction between sodium hydroxide solution, which is clear, and if you mix it with copper chloride solution, which is blue, just like the last one, right? So all solutions that have copper are usually green or blue. And it turns out that copper hydroxide can't be dissolved in water. So when you mix these two together, it forms something, remember, that we called a precipitate. The precipitate is basically a powder that forms. That powder is a solid. Right? And then we have a solution of sodium chloride left. And so that reaction is underway here. All right. that is it. Those are your 5 main types of chemical reactions. You guys are going to get some practice with that this week, and I will see you soon.